we're going to learn about algebraic fractions. Now, you might be wondering, why are we dealing with fractions? And I think an important question to ask first is, what is an algebraic fraction? So we know regular fractions. We know that fractions are just a numerator. So I'm just going to say a numerator over a denominator. And there we go. Top number divided by bottom number. There's a fraction. But let's slow it down a little bit. If we try and remember when we learned about what an algebraic expression was, we said there was something that involved or could involve variables as well. So that means that an algebraic fraction is a situation where the numerator and the denominator can now be algebraic expressions. Okay, I just want to remind you guys one more time that an algebraic expression is different from an algebraic equation. If you remember, an algebraic equation has an equal sign, whereas an algebraic expression doesn't necessarily have an equal sign. So let's just come up with any random example of an algebraic fraction. It could be where the numerator has variables, so x squared plus 2x over 3. Or it could be one where the denominator has some variables. So this could be 2abc plus 4b. Or it could even be a situation where the numerator and the denominator have variables. So something like x squared plus 3x plus 2 over 5x plus 3. Well, those look really complicated. And now it's going to be your job to simplify them. But don't worry, I'm going to show you some really easy steps. Now, you might be wondering, why am I even learning this now? We've just been focusing on factorization. Why are we talking about fractions right now? Well, the really cool thing is that to simplify algebraic fractions, we're just going to follow 2 steps. First one, factorize the numerator and the denominator if possible. So there you go. That's where the factorization comes in. Then the second step will be to cancel out any identical terms. Now notice I said identical terms. They can't be similar, they can't be kind of the same, they can't be cousins, they can't be best friends. They have to be identical. So let's put this into practice. Let's try some examples. Now we're going to just remember, first step is going to be to factorize the numerator and the denominator if that's possible. Then the second step is going to be to cancel out any identical terms. Let's do an example here and see what on earth I mean. Here's our numerator. So let's just write it over here for the first one in case you're still unsure of what a numerator and denominator really mean. So the numerator is going to be 4x squared plus 8x. And the denominator is going to just be 4x. Okay, so remember, numerator what's above the fraction line and denominator what's below the fraction line. So if the first step is to factorize the numerator, let's try factorizing the numerator. The first thing we're going to ask ourselves, and I hope you remember this from the flow diagram that we went through, is there a common factor? Well, if I look at just the numerator, I can see that yes, there is a common factor. I can see that I can take out 4x as a common factor. So what's left? 4x squared divided by 4x, that will just leave me with x. Plus 8x divided by 4x, well, that will just leave me with plus 2. Then can we factorize the denominator? Well, the denominator is just one term, and factorizing is to go down to one term. So no, we can't factorize the denominator. So this is just going to be 4x at the bottom. We can't do anything there. But now step 2 is to cancel out any identical terms. And would you look at this? I can see an identical part there. The 4x and the 4x are identical, so I can cancel them out. And all I'm left with is x plus 2. And guess what? That's your answer. So if we've simplified all of this down to just x plus 2. Let's do another example. Now we're going to look at 4a squared minus 16 over a minus 2. So let's factorize the numerator. Is there a common factor in that numerator? Yes, there is. So 4 is the common factor, and I'm left with a squared minus 4 over a minus 2, because I can't factorize that denominator. It's as simple as it can go. But be careful, you're not finished factorizing. If you look inside this bracket over here, you can see that there are two terms that are perfect squares and there's a difference. So we're going to do dots, or the difference of two squares. So I can keep factorizing that numerator. I'm going to say that would be a plus 2 and a minus 2. So then I can divide all of this by my denominator. If I pop brackets around this, which I'm allowed to do, I can see that I can cancel out that entire bracket of a minus 2. And what's left? Well, just a 4 times an a plus 2. And we can leave our answer just like that. So there we go. We factorized the numerator as far as we could go. So there we factorized it a bit. Then here we carried on and factorized it as far as we could go. Then from there, we found what was identical and we canceled those out and we wrote down what we were left with. Okay, let's try example number 3 here. This one's looking a bit complicated. So, is there a common factor that we can take out the top, the numerator? Nope, no there isn't. Now let's see how many terms are in the numerator. Now I know that this whole fraction is just one term, but if I look just at the numerator, I can ask myself how many terms in there? Well, there's 3, and it does have the form a squared plus ba plus c. So that is a trinomial. Let's see if we can factorize that. Okay, so to factorize our trinomial, we're going to put down our two brackets. We're going to put an a here and an a there. We're going to put down our pairs of factors that would make 10, which is our c value. So we're going to say 10 times 1, 5 times 2, or negative 10 times negative 1, negative 5 times negative 2. And then we want to add up those pairs until we get our b value of minus 7. So 10 plus 1, no, that's going to give us 11. 5 plus 2, ooh, that gives us 7, but our b is a negative 7, so that's not going to work. Minus 10 minus 1, that's minus 11. Minus 5 minus 2, now that will give us minus 7. So in our brackets, minus 5 minus 2. Then we can now move on to factorizing our denominator. First question we ask ourselves is there a common factor? And yes, there is a common factor. So let's take our 2 as our common factor first. 2a squared divided by 2 will give us a squared. Minus 8a divided by 2 will give us minus 4a. Minus 10 divided by 2 will give us minus 5. And you might be tempted to stop right there. But remember, we still have to look at what's in this bracket. And if you look there, we have another trinomial. Let's see how we can factorize it. Let's look for the factors of negative 5. So that'll be 5 times negative 1, negative 5 times positive 1. So we're going to add them together and we're trying to get to negative 4. So 5 minus 1, that gives me positive 4, so that's not the one. Negative 5 plus 1, that's going to be the one because negative 5 plus 1 is 4, negative 4. So we're going to leave our numerator exactly as it is, but now we're dealing with the denominator. So we write down 2, and then we open up our two brackets. We pop down an a in both of them. Then we're going to put a minus 5 in one of them and a plus 1 in the other. So minus 5 and plus 1. Now we can get to step 2 because we fully factorized the numerator and we fully factorized the denominator. I see that there's an a minus 5 and there's an a minus 5. So we can cancel those out. Remember, it has to be the whole entire thing. We can't just be like, oh, there's an a and there's an a. That is not going to work. I really, really hope you understand. I'm canceling out entire factors. I'm not just canceling out individual terms. So now I ask myself, okay, so what's left? Well, at the top of my fraction, I have a minus 2 left. And at the bottom of my fraction, I have a 2 and an a plus 1. And there you go. That's my answer. Let's move on to example number 4 here. Same thing as before, let's factorize the numerator, factorize the denominator, and cancel out. So, first question, is there a common factor in the numerator? So we're looking over here. Is there a common factor? Yes, there is. I'm going to take out 5 as my common factor, and I'm left with x squared minus 9y squared. Now, I'm hoping you realize straight away that's not fully factorized. So let's just keep that in the back of our minds. Now, let's factorize our denominator. First thing we ask ourselves is there a common factor? Yes, there is. We can take out 5 as a common factor and we'll get x plus 3y. Okay, so now we remember that this dude over here is not fully factorized, so we're going to keep going. There is a perfect square, there is a perfect square, and there's a difference. So we're going to do dots. So we've got x plus 3y and x minus 3y. Remember, guys, if you're struggling with factorization, you can either re-watch previous videos or you can just let me know and I will help you out. Okay, and then we've put the denominator as is because there's nothing more we can do there. Now we start looking for things that are identical. There's a 5 at the top and a 5 at the bottom that are just chilling on the outside by themselves, so we can cancel them out. Then an x plus 3y at the top and an x plus 3y at the bottom. So all that's left is an x minus 3y at the top. And there you go. We've simplified what looked like a really complicated fraction into something that looks much more reasonable. Let's move on to our next example. And just like before, we're going to try and factorize. So first thing we ask ourselves, I'm sure you're all rolling your eyes by now, is there a common factor? So looking at the numerator, yes, there is a common factor. I can take out 4 and I'm left with x plus 3. Now I'm going to ask myself the same question in the denominator. Is there a common factor? Yes, there is. It is 2. So I'm left with x squared plus 8x plus 15. Now let's do the next step. Let's just double check, is our numerator fully factorized? Is there anything I can do in there? No, there isn't. So I'm just going to leave it as 4 times x plus 3. Now let's ask ourselves the same question in the denominator. I'm going to pop down that 2 and I'm going to ask myself, is there anything else that I can do inside this bracket? Can I factorize? And I'm really hoping you see that this is a trinomial because it is in the form ax squared plus bx plus c. In fact, our a is equal to 1, our b is equal to plus 8, and our c is equal to plus 15. Let's find our factor pairs that come up with 15. So there's 15 times 1, negative 15 times negative 1, 5 times 3, negative 5 times negative 3. Okay, let's see which combination of these is going to give us plus 8. 5 plus 1 is going to give us 16. That's not going to work. 5 plus 3, hey, that's going to give us plus 8. So we go back here, we pop down our 2 brackets, and we know that our variable was x. So there you go. We've got plus 5 and plus 3. And now it's fully factorized. Our next step is to look for exactly like terms. So x plus 3 and x plus 3. Now you might be tempted to stop, but be careful. You know in your head, 4 divided by 2 is going to give us a 2 left over at the top. So we can cancel this out with one of the sets of 2. Remember, 4 can be written as 2 times 2. So I could cancel this 2 out with one of them there, and I'd just be left with a 2. And then at the bottom, we're just left with x plus 5. Be careful, this one can be tricky. If we have numbers at the front there that aren't identical, we still have to see if we can simplify them. We still have to ask ourselves, what is 4 divided by 2? Well, that gave us 2. Let's move on to our last example. Now, this one is a bit of a challenge, so bear with me and let's try our best. Our numerator and our denominator already kind of look factorized, but let's just see what we can do. 2a plus 3c, I can't factorize that anymore, so I'm just going to leave it just as it is. A squared minus 25b squared. Okay, there's 2 terms, there's a difference, and they're both perfect squares, so we could still do dots there. So we would say a plus 5b and a minus 5b. Okay, cool. So we split this one bracket into both of those. Now let's see if there's something that we can do in this denominator. 2a plus 10b. Is there a common factor we can take out? Yes, there is. I can take out 2 there. So 2 times a plus 5b. Okay, so here again, we split this one into 2. Now 4a squared minus 9c squared, no common factor, but there's two terms, a difference, and they're both perfect squares. So this can be 2a plus 3c and 2a minus 3c. So again, we split this one bracket into two factors. All right, so let's see if we can cancel some things out and simplify this. There's a 2a plus 3c. Hey, there's a 2a plus 3c, so those guys can cancel. There's an a plus 5b. There's an a plus 5b. Okay, a minus 5b, no a minus 5b at the bottom, and no 2a minus 3 at the top, no 2 at the top. So what's left? Well, at the top, I have a minus 5b. You can still keep it in the brackets if you prefer. And at the bottom, I've got 2 times 2a minus 3c. And that's it. That's how we're going to simplify our algebraic fractions. So let's just go over the rules one more time. So first, we factorize. We factorize the numerator and the denominator as far as possible. Sometimes we'll only be able to factorize the numerator, and sometimes we'll only be able to factorize the denominator. But we do that as far as it can go. Meaning that if there are multiple steps to factorize one of them, we need to remember that. Step 2 was to cancel out any identical brackets. Please remember they have to be identical. They can't be kind of similar. And then step 3 that we didn't add before is we have to simplify any numbers that we may have. You may remember that in one of these examples, we had 4 over 2, which we had to remember to simplify to 2. Something important to bear in mind is that when we're canceling out our brackets, we have to cancel out something from the top with something from the bottom of the fraction line. They can't both be at the top of the fraction line or both be at the bottom of the fraction line. That wouldn't make any sense, unfortunately. Remember, it's like saying 5 divided by 5. We could cancel them out and we get 1. Or x divided by x. X goes into x one time, but one has to be at the top and one has to be at the bottom. Okay, guys, that's it. That's all you need to know about algebraic fractions. So now it's your turn to go and practice. Remember, if you're struggling, just let me know. Good luck.